this chapter, we will be looking at topics related to measurement. In this lesson, we will be finding the volume of some standard geometric shapes.
Okay, so now we're going to take a look at volume. And what volume is the amount of liquid or space required to fill an object, or is the space taken up by an object, right? And so these are cubic units, because as soon as we start talking about volume, we're talking about a three-dimensional measure here. Okay, we got the length, the width, and then the height here. Now, this lesson here is substantially easier than surface area. With surface area, you basically have to tear this thing apart in terms of its faces. But you don't have to do that with volume. Actually, it turns out the formulas are a fair bit easier here. There's typically just one term to these volume calculations. So here's the object that we got here. The cube is just going to be length times width times height. I mean, this is the beautiful one. This is why we call them cubic units. The easiest thing to work with, just going to be length cubed here. However, if it's a rectangular prism, and I'm pretty sure everybody here is going to be familiar with this, it's just going to be the product length times width times height. Now think about this. Length times width is the area of the base. So we're simply multiplying the area through by the height. That's all we ever do here. Length times width times height. Cylinder, same sort of thing. We take the area of the base and we're going to multiply through by the height. So the area of this thing is going to be pi r squared, and then we simply multiply by the height to get the volume. Now, cone, this is kind of an interesting little relationship here. Think about a cone. A cone is simply a cylinder where we've chopped off a bunch of that material there. Now, how much did we get rid of? Well, it turns out the answer is 2/3. So what you're left with here is 1/3 of that cylinder. If you cross out the 3 here, just look at what you're left with. Pi r squared h, that's the volume of a cylinder. And what we've got here is 1/3 of that. We're dividing it by 3, or 1/3 pi r squared h. Just really fascinating that that's how a cone works. Turns out that particular relationship also works with pyramids. Okay, so when you've got a square-based pyramid, and actually we're going to separate this into square and rectangular-based pyramids, but the result is the same here. Think about what the volume, if I had this as a prism here, okay, the volume here would be length times width times height. In this case, it would be b times h, so b squared times h. But when it comes to the pyramid, the actual volume of the pyramid is simply 1/3 of that. And if we're working with a rectangular-based pyramid, the volume, if you were to create the prism here, the volume of the prism would be length times width times height, so L times B times H. And again, the volume of the pyramid that we're left with here is only 1/3 of that. Just really interesting that third keeps popping up. Finally, we've got a sphere. And again, we're not going to go into a lot of details as to why this works here, but the formula for the volume of a sphere will be 4/3 pi r cubed. And later on when you get into calculus, you're going to see some really interesting relationships here. You'll see why this works as nicely as it does. And if it's a hemisphere, and this one is much clearer than it is with the surface area, it's simply going to be half of this. So you divide the whole thing by 2, and we're simply going to simplify that by dividing that 4 by 2. So we get 2/3 pi r cubed. So those are the formulas that you need to be familiar with. You won't have to memorize them. You will be provided with these things. But you really got to know how to work with them. So that's what we're going to do right now. We're going to take a look at some examples. Okay, everybody, so we're just going to find the volume of a whole bunch of different shapes here. Just really quickly applying the formula, or the formulae. So here we go. This is a cone, okay? So the volume for the cone is going to be 1/3 pi r squared height. I've got 1/3 pi. I know that the radius there is 5 squared times, I don't know what the height is. That's not the height. That 14 is this distance right here. So that ain't it. So I got to figure out what that height is. Well, fortunately, that forms a right angle triangle, so I can use the Pythagorean theorem. I know that h squared plus 5 squared is going to equal 14 squared. 5 squared is 25, and h squared is going to be 196. So I'll just bring that 196 over to the right-hand side, and so h squared will equal 171. This is kind of a gross little number there, but that's okay. I will take the square root of that. That should produce a positive and a negative, but I'm only going to take the positive one because that's the only one that makes sense. So the height here is root 171. I'll put that over here, 171, and then we'll just go to my calculator. So this will become, 1 divided by 3 times pi, 1/3 pi, r squared, so times 5 squared. I mean, I could have just put 25 there, but anyway, times the square root of 171. Press enter, and there we go. So let's say to the nearest tenth, we got 342.3. 342.3 yards cubed now, because we're in cubic units. This one here, this is obviously a rectangular prism. So the volume is going to be length times base times height. So that's going to be 13 times 9 times 5. And that's a substantially easier calculation here. But we'll go to the calculator real quick. 13 times 9 times 5. 585 inches cubed. C. A sphere. And we're told that the radius is 14, so that makes this even easier. So the volume of the sphere will be 4/3 pi r cubed. So 4/3 pi 14 cubed. Okay. So that will be 4/3 times pi times 14 cubed. Oh, there we go. 11,494.0 feet cubed. Now, I should point out right now that what I've seen a lot of people do with this formula here, and it really has to do, I mean, the only explanation I give for this is that they're really not paying attention. I see people put squared there all the time. It's got to be one of the more common errors here is to just simply not write this formula correctly, and then as a result, as soon as you see the square there, you don't even think about it. You just kind of do the math that you've told yourself to do here. And then your answer is really quite wrong. So please pay attention to that. Make sure that you've copied the equation down correctly when you use it. Here, looking for the volume of a square pyramid here. At least I'm assuming it's square. You're not specifically told, but I believe that's the implication here. So once again, this is going to be 1/3 length times, well, actually, sorry, it's going to be length squared times height. I think I should say it like that because it is a square pyramid. That's going to be 1/3 8 squared. Now the height, I don't know. I don't have it here. I know that the slant height is 12. So I'm going to have to use the Pythagorean theorem. And I know that if I was to follow this line all the way across, that would be 8. Because that would be the same as this side right here. So this little bit that I need here is just 4. So 4 squared plus h squared should equal 12 squared. Okay, we'll go through this a little bit quicker here. Because I know that 12 squared is 144. And I know that 4 squared is going to be 16. So if I bring that 16 over, 12 squared, 144 minus 16 will be 128. Okay, and I'm going to take the square root. And so this will be the positive square root of 128. Actually, we can simplify that down substantially. That, I believe, is going to be 8 root 2. 8 root 2, yeah, because there's going to be, that'll be 2 to the 7 there. 2 to the, yeah, 2 to the 7. Yeah, there we go, 8 root 2. So up here, we'll put here 8 root 2. Plug that into my calculator. So that will be 1/3 times 8 squared, or 64, times, sorry, off the top of my head I couldn't remember what it was, so I'll just go root 128. And we get 241.4. Approximately 241.4 inches cubed. Down here, same sort of thing, except this is now a rectangular pyramid. So this will be 1/3 length times base times height. But in this particular case here, I am told what the height is. So this is not an issue here. It's going to be 1/3, length will be 20, base will be 30. Actually, you probably could have switched those around here. And then the height there is going to be 15. And so what we've got here, it'll be 20 times 30 times 15 divided by 3. Actually, that works out nicely. That's just 3,000. centimeters cubed. Okay. And now one more. Cylinder. So the volume of the cylinder will be pi r squared h. Now in this particular question right here, they've gone out of their way to make this a little awkward simply by giving us the diameter at the bottom there, because I don't need the diameter, I need the radius. But that's okay, just divide that by 2, that's easy. And so this will be pi times 9 squared times 21, and to the nearest tenth, which is what we've been doing here, 5,343.8 millimeters cubed. There we go. Just very, very straightforward application of the formulas here. There's no multiple parts to it. Just got to grab the piece that you need, plug it in, calculate it, and away you go. Volume is good. So in this question we read that a rectangular pyramid can hold 1,250 cubic feet of water. Okay. The base of the pyramid is 15 feet by 10 feet. And what is the height of the pyramid? Okay. So we know that the volume of a pyramid is going to be 1/3 the volume of the corresponding prism, rectangular prism, which would be length, width, height, or length, base, height here. We are told that the volume is 1,250. We know that the length of the base here is 15. We know that the width is 10. The thing that we're missing is the height. And actually that's the thing that we're being asked for here. So that's actually a really, really convenient little problem here. So actually I'm going to evaluate or simplify what's on the right-hand side here first as much as I can. 1/3 of 15 is 5 times 10 is 50. And so when I divide that through, golly, what am I going to get here? Am I going to get 120? I am going to get 125. Sorry, I'm going to get 125 divided by 5, just 25. 25 is equal to h. So this thing is going to be 25 feet, right? 25 feet high. I'm just going to double check that I did that right here. Yep, looks good. Anyway, so there we go, real quick and easy. So this question says that this cone can hold 870 centimeters cubed of sand. What is the height of the cone to the nearest tenth of a centimeter? Well, this is very similar to the one that we just did. So volume, the volume of a cone here is going to be 1/3 the corresponding prism. Okay, so our volume, we already know that the volume is 870. We know that's going to be 1/3 of pi. Now r in this case is 9. So this will be 9 squared, and then we're left with just the height here. Just like before, what I'm going to do is I'm going to simplify this a little bit, because I know, okay, I know that 9 squared is going to be 81, but then we're going to get 1/3 of that. And 1/3 of 81 is going to be 27, so 27 pi times h. And so now to get h by itself, because bear in mind it's being multiplied by this 27 pi, I'm going to divide by that, so we'll get 870. Whoops, I don't know why I wrote that out like that. That was weird. 27 pi is equal to h. And that is definitely a bit of calculator work here. And I know we've been talking about this, but I just want to make sure this is abundantly clear how you would handle this when you go to your calculator. So we would type 870. But remember, because I'm dividing by two factors here multiplied together, I have to put parentheses around this, because if I don't, 27 pi. If I don't put the parentheses there, then I'm simply going to be dividing by 27 and then multiplying by pi at the end, and I don't want that. Okay, I want that multiplication to be happening in the denominator. So I press enter, and there's our solution, and then the question was to the nearest tenth of a centimeter. So to the nearest tenth, okay, height is going to be 10.3. 10.3 centimeters. That's what we're looking for. So this question says that a glass paperweight has the shape of a square pyramid. Alex measured the edge of the base to be 3 inches. Okay, so it's a square pyramid, so we know that those are both 3 inches there. And the slant height is 4 inches. What is the volume of the paperweight to the nearest cubic inch? All right, well, it's a square pyramid, so we know that this is going to be 1/3 the volume of the corresponding period, which would be base squared times height. Okay, so let's be 1/3. We already know that the base is 3, so that's going to be 3 squared times the height. Now that's where we stop here because we don't actually know the height here. I've got the slant height, and we understand why Alex measured that because that is actually an easier thing to measure. You just put the tape measure along there, pull it up, and you can take it right to the top here. It's more difficult to measure the actual height of that pyramid here. But fortunately for us, we have a theorem that helps us deal with that. So this triangle right here is a right angle triangle. So I can use the Pythagorean theorem. I am looking for the height. That's the thing that I'm missing, but I know the hypotenuse. Now be careful with this down here. If I was to extend that line all the way across, that would be 3. Just like this edge here is 3. But the part of the triangle that I need isn't that all the way across here. It's halfway, so it's got to be 1.5. So I'm going to do this over here. So h squared plus 1.5 squared is going to equal 4 squared. So h is going to equal, well, I've got 4 squared, which is going to be 16, and I'll subtract 1.5 squared, and I'll square root that. I'm just going to go right to my calculator and have my calculator do that for me. So just the square root of 16 minus 1.5 squared, I don't know what that is off the top of my head. Okay, so to the nearest tenth, I've got 3.7. Okay, so roughly 3.7 here. Now when I plug this into my calculator in a bit to find the actual volume, I'm going to use the whole decimal that I calculated here. But for right now, this is good enough to put in. So multiplied by 3.7. And so now 1/3 of 3 squared times 3.7. So now bear in mind, 1/3 of 9 is just going to be 3. So really all I have to do is multiply 3 by that 3.7 that I calculated earlier. And I am going to get to the nearest cubic inch. I got there 11 cubic inches. Okay, so the only real trick to this question was finding that height based on the information that I was given. Now in this question we read that a cylindrical water tank with an open top has a volume of 5,702 meters cubed and a radius of 11 meters. What is the height of the tank? Okay, now this question's maybe it's just a tad more difficult because the picture's not here. So we just give ourselves a really quick diagram, We know that the radius here is going to be 11 meters. Okay. We know that it has a volume of 5,702 and we are asking for the height of the tank. Well, so we don't know what that is, but we know that the volume of a cylinder will be pi r squared h. And I will just plug in what I know. I know that the volume is 5,702 meters cubed. I know that the radius is 11 squared. What I don't know is the height. But I do know, okay, that if I have these two pieces here and they're being multiplied by h, if I want to get h by itself, I simply have to divide by those two. So h will be equivalent to 5,702 divided by 121 pi. That 121 is that 11 squared. Now I got to go to my calculator to evaluate this. And I'm going to show this to you again here because I want you to see repeatedly what I'm doing here. So 5,702 divided by, say it again, because there are two terms down there, I need to have parentheses around that denominator or else I'm not going to be dividing by what I think I'm dividing by. The calculator will do exactly what I tell it, not what I think it should be doing. So 5,702 divided by 121 pi, press enter, and you can see the number that we're looking for here is definitely 11. Okay, so the height here is going to be approximately, 11. Wow. Well, that number there is obviously not 11, that's 15. The answer here is 15. Okay, in this question we read that a square-based pyramid has a volume of 560 centimeters cubed. It's got a base with an area of 40 centimeters squared. What is the height of the pyramid? All right, they set this up really, really nice for us. We've got this square pyramid, okay? We are trying to get the height of the pyramid, but bear in mind, oops, sorry, what I should have done is this right here. Bear in mind what they've told us here. We know that the volume of a pyramid, whether square or not, is going to be 1/3 the volume of the corresponding prism. Now in this case here, because we're told it's a square-based prism, it's going to be b squared times height. Now, we already know that the square-based pyramid has a volume of 560. So I already know that that V is going to be 160. I know this is 1/3. And actually, think about this. B squared, okay, this is base, because this is a square pyramid. Bear in mind that B squared is simply going to represent the area of the base. And we were told what that is. We're told that that's 40. Okay? And then we multiply that by our H. That's our formula. Now, to get H by itself, I have to move these terms over. But this is a little different this time. In previous questions like this, what I could do is I had the ability to simplify this quite nicely. In this case, I don't, because 40 is not a multiple of 3. So what I'm going to do is I'm going to multiply both sides here by 3 first. Okay, that's going to get rid of that 1/3 there. So once that 3 is up here, now I'll divide by that 40. And this will be what H is equivalent to. So now I just go to my calculator. This one's quite easy. 3 times 560 divided by 40. And I get that my answer here, H, is equal to 42 centimeters. Now in this particular case, when I enter this into my calculator, I don't need to worry so much about putting parentheses around the numerator. And the reason for that is because the calculator will assume, when I multiply them together, that they are in the numerator. Okay, when you multiply numbers together, the calculator always assumes that you're talking about the numerator. And then whatever you divide by, that goes into the denominator. So because I'm only dividing by that single number, 40, the calculator had no problems with me just entering 3 times 560 divided by 40, gave me the correct answer. In this question, we are told to calculate the volume of a cube with a surface area of 54 centimeters squared. Okay. So the volume of a cube is simply going to be the edge cubed. I'm going to use an E there for edge because if I use S for side, everybody complains that my S looks like a 5, so I'm not going to do it. So the edge of the cube, right? There we go. Edge, edge, edge. But what we're told is what the surface area is. But we know that the surface area of a cube is going to be 6 times the edge squared, because there are 6 faces here. We know that that's going to be 54. Now, the reason why this information is given to us is because we don't know what the edge is. I need to use this to get the edge before I can figure out what the volume is. So we've got to solve this little equation. So the first thing we got to do is bring over the 6, divide both sides by 6. And so now E squared is equal to 9, which means E has got to be 3. Now it could be positive or negative 3, but because we're talking about the length of an edge of a cube, we know that's got to be positive. And so therefore, we know that the volume has got to be 3 cubed, and 3 cubed is 27. And in this case, the units are centimeters cubed. And there you go.